Yeah, all the students, now we are going to discuss about our next concept in that our periodic table, that is only, yes, ionization energy. In the last class, we already completed about atomic size and how it is affected. And now we are going to discuss about what is ionization energy, yes, and how it will be affect the our whatever our yeah, as there is a lecture number 3, that is in that one ionization energy is there. Page number 51. Yeah, all the students, once check it. Already we are discussed about ionization energy. In the whatever the first class it is there, in that one only we are completed, that is already. Now we are going to discuss about the remaining concept, whatever the ionization energy, clearly the information, what the effects are affected that ionization energy, everything we are going to discuss in this particular topic. Yes, and that is the what actually when you are taking here, what is the mainly ionization energy means, when we are taking it is a positive charged particle, and here an outermost electron it will be contained here. Yes, somewhat here it is a content. Got it or not? Yes, when there is a energy is a provide to it, automatically it is a came out from the what actually from this orbit. Yes, why? Because we already discussed according to the Bohr atomic model what? Yes, when we provide some amount of energy to the electron, it will be observed that energy and it will be not a contained in that particular orbit only. Yes, and it not sustain in that particular orbit only, it will be emitted out from that orbit. Got it or not? It is emitted out from that orbit. Yes, I hope you got it here. Yes, and why? Because suppose you are completed your 8th class, again you are sitting in a 8th class only. No. Yes, automatically you got somewhat energy to go to 9th class. Okay, yes, like that only. Electron is not a contained in that particular orbit only. When it is observed the energy, automatically after observing that energy, it will be emitted out from that orbit and it will be go somewhere. Got it or not? I hope you got it here. Yes, now this is only called ionization energy. Once again I repeat it. The energy required to remove the electron from outermost orbital. It is only called what? Ionization energy. Yes, this is about first concept. Next, there is ionization energy is so many things are there in ionization energy. Yes, the amount of energy required to remove first electron from the neutral atom is called the first ionization energy. The energy required to remove the electron from the unipositively charged ion is called the second ionization energy. Similarly, the third and fourth ionization energy are the ionization potentials can be defined as the same way. Okay, clear or not, all the students? Suppose what is this ionization energy? Suppose you take here there is aluminum. Okay, clear or not? Aluminium structure is looks like this.
Right.
Hope
Now,
you got it here?
yep. Question answers.
Mute yourself.
Let's answer the following question, please. 1, 2, 3.
Yeah, there is a what we are considered. This is the first orbit. Aluminium. Suppose I am taking aluminium. Atomic number is 13. Okay, clear or not, all the students? The aluminium atomic number is 13. And now there is, we are taken one electron here, one electron, two electrons are here. You know very well the electronic configuration of the this aluminium is about 1s2, 2s2, 2p6, and as well as the 3s2, 3p1. Okay, clear or not? And here there is a how there is we are consider the yes about our atom structure. Yeah, looks like this. There is a one. There is a totally. Yeah. How many electrons are there? This is the first orbit. K orbit. It is a called. Next we called L orbit. Next we called M orbit. Okay. Now how many orbits are there? 3 orbits are there. Which one is the valency orbit? The third orbit is become the valency orbit. The third orbit is become what here? Valency orbit. In the valency orbit, how many electrons are there? 3 electrons are there. Got it or not? Suppose I provide some amount of energy to this electron. Automatically, this observed that, and next there is no further energy level is there. Yes, and that automatically came out from the yes, where came out from our aluminium. Now aluminium is become what actually +1. This is called positive ion. Why? Because it is become a +1. Why? Because it is become a +1. Yeah, there is how many particles are there? There is 2 particles are here, and 8 particles are here. The 3 particles are here. Automatically, one electron is came out from that. There is aluminium also contain 13 protons, 13 electrons. You know very well. What is that? Atomic number of aluminium is 13. What is the meaning of 13? Meaning of 13 is, yes, it's a contain 13 protons and 13 electrons. We removed one electron. How many electrons are there here? 12 electrons are only there here. How many electrons are there here? 12 electrons are only there here. Okay, now yes, there is 12 electrons. How many protons are there here? 13 protons are there. Automatically, it is become what? One of the positive ion is more or not here? Yes, there is 13 plus, and as well as the 12 are minus. How much positivity is there? Unipositivity. Got it or not? There is whatever the electron is removed at the ground level. Ground level is nothing but what? Ground level is nothing but whatever its original level is there, that is called ground level. Got it or not? Excited level. We called excited level. Excited energy state. Okay, now which one is called excited atom? Automatically it contains some amount of excess energy, whatever contain actually. Whatever adequate it is there, more than that it will be contained. It is called what? It is called excited atom. Otherwise, it is not contain any other energy. It contain only the energy which are okay. It's actually it is a contain. Means what? 13 electrons, 13 protons, and neutrons are fundamentally aluminium. How it will be there? In the same manner, it will be available. It is called what? It is called a ground state. Any energy we provide, it is called excited state. Got it or not? I hope you got it here. Yes, now there is we provide energy. Because of that, there is electrons are somewhat losses. Okay, now yes, and that is yes, positivity is a contained. Unipositivity ion, it is a contained inside. And here unipositivity is nothing but what? A +1 means what? One electron losses. Yes, how it is losses? We provide some amount of energy. That energy is only called what? Ionization energy. That is called a fundamental ionization energy. Initially, just to we remove only one electron from the yes our ground state atom. It is called fundamental ionization energy. The equation we written as yes, there is what the main atom it is. Okay, now we are taken it is one electron from it automatically M plus minus I1. Okay, clear or not? M is become plus, and as well as it is become what actually M plus here plus minus I1 it will becomes. Okay, clear or not, all the students? Yes, positive ion it will become, and one electron is a comes from it, and we provide our I1. I1 is the what? Fundamental ionization energy. This is called a fundamental ionization energy. I hope you got it here. Yeah, next one. After this, yeah, there is we are consider what actually we consider there is a positive ion. Automatically, it is become what unipositivity. It is there. And next we have after this aluminium +1 it will becomes, and then after again we are remove one more electron from it. Okay, now yes, at that time there it will be become what more energies are required for us. Why? Because more energies are required for us. It is opposed by somewhat a positive ion. Okay, clear or not? Somewhat a positive ion it is. Okay, clear or not? Yeah, there is a one more ion it will be there. Yes, and we want to remove the one more. It is a become aluminium +2. There is we have to provide I2 energy. The I2 is the what? Secondary ionization energy. Next we are taken it is aluminium +3. It will become what? I3. Automatically it is the what it is? The third ionization energy. Yes, next aluminium. Yes, a +4 is a possible, not a possible here. Why? Because already they are bounded with the nucleon. Okay, and aluminium is valence is a 3 only. That's why there is a third ionization energy is only yes possible for the aluminium. Okay, now but in which one in this particular total process? Yes, which is become the yes highest ionization energy? Yeah, when it is a more positive, more cation nature it will be there, automatically we require more amount of energy to remove the electron from it. Okay, clear or not? We require more amount of energy remove the electrons from it. Okay, this is only called what? This is only called yes ionization energies. Okay, when we are taken here I1 is a less than, there is a what actually I2. I2 is a less than I3. It's a very important question for you. Yes, they may have given a what suppose silicon they given. Okay, now yes, how many possibilities are there? 4 ionization energies are possible for it. Okay, depending on the valency, there is a whatever the valency orbit electrons are there, we have to remove. Okay, but only not one electron. It is a possible to remove. There are all electron in the valency orbit, but it is very difficult process. The single electron is the easiest, and compared to the 2 electrons, you have to remove the more energy required. 3 electrons further we are provide the more energy to it. Like that, the energy have to should increase more and more. At that time only there is it is a yes become as a one particularly yes ionization energy per ionized energy utilized. Otherwise it is may not utilize. Yes, we want to provide only I1 energy. There is no second electron may came out, but the reason only the thing that is become positive ion. What you understood from this one? The question may ask for you. Ion is a required more ionization energy, or atom is a required more ionization energy? Yeah, ion is a required more ionization energy. Okay, clear or not? Sir, suppose there is all positive ions are only formed. Yeah, there is ionization energy when we provide to the any particular atom, that should compulsory become it is as a positive ion only. It's not a become negative ion. It is only become as a positive ion. Yes, I hope you understood it is. Yes. And next, we have the factors affecting the ionization energy. Next concept. I hope you understood all the students. There is a what? When we are taken one atom, first we take one electron. It is called fundamental ionization energy. In case we are taken a second electron from that atom only, that is called secondary ionization energy. In case we are taken a third electron from it, third ionization energy. Got it or not? Yes, like that. Here, uni positivity. Yes, uni negativity. Yes, these all you have to should know. When it is called uni positivity, when we remove one electron from it, it is called uni positivity. When we remove the two electrons from it, it is a become what? A there is a di positivity, it is there. Yes, like that, there is a amount of ionization energy is increases with increasing of positivity. Okay, now, yes, this is the main component, and the equations are also important. All the students, please note down that all the equations, what is the fundamental ionization energy, yes, secondary ionization energy, these all the things are compulsory for us. Yes, next we are going with the factors affecting of ionization energy. Next component is factors affecting the ionization energy. Yeah, what the factors are affecting ionization energy? Yes, first thing is effective nuclear charge. Yeah, effective nuclear charge. Which is called effective nuclear charge here? Yes, there is already we are discussed now only. There is a positivity is contained in the nucleus. There is any negativity is there in a nucleus? No. Okay, now nucleus contain fundamentally two particles only. One is a neutron, another one is a yes. What is that? A proton. One is a neutron, another one is a proton. We are contained. Yes, one is a neutron. It is there. Another one is a proton. It is there. Okay, clear or not? This is called effective positivity. It is called what? Effective positivity or effective charge. Okay, clear or not? Yeah, you know very well. On the electron, there is a one force is there. What is that force? Coulomb's inverse forces are working on it. Yes, and on the electron outermost orbit, whatever there on this particular electron, what happened? There is a somewhat forces are working. You know very well. In our physics, there is a Coulomb's inverse square law. Yes, already you have in your regular syllabus, forces. Yes, electrostatic forces. When you take a balloon and you rub it with your head or otherwise any paper, afterwards you make it is into pieces. Okay, now when you make it is somewhat distance and attracted the paper pieces to that balloon surface. Okay, you already completed that experiment. How it is possible? You know very well. It is a possible because of electrostatic attraction forces. It is a possible because of what? Electrostatic attraction forces. Here in our atom also, there is a between electrons and as well as the protons, there is a one charge force is there. That is only called Coulomb's forces. Coulomb's attraction forces. Here only the attraction forces. Somewhere times it is a repelling is also there, but there is a no repelling in our atom between the electrons and as well as that whatever our nucleus. There is only what is action is there between these two things, attraction only. Got it or not? It is a positive charge is attracted this electron. Got it or not? The positive charge is attracted this electron. This is only called effective nuclear charge. In the nuclear, there is a protons are there. The protons are increases. Actually, now when an atom we are considered, there is a protons are not increases. Electron decreases nothing but proton charge is increases. Okay, that is only called effective charges. Already we are discussed in aluminum. In the aluminum, one electron is a losses. There is a 13 protons are remain like that only. Electron number is a become 12 electron only. Now the positivity is increases or not? The positivities are coming from where? From the nucleus. That is only called our nuclear charge, effective nuclear charge. That is increases. What happened? Ionization energy also increases. Why? Why the ionization energy is increases? Yeah, you know very well. There is a more attraction is there. Where on the outermost orbital, the nuclear is attracted more. Okay, you know very well the Q1 and Q2 are the two charges. Between the two things, there is a one force is working. That is depending on the product of the strength of the charges, and it is inversely proportional to square of the distance between them. This is only called electrical force. Okay, here there is a charges product is a decreases or not? Yeah, decreases here. Okay, clear or not? Positivity is increases. Okay, na, and negativity is a decreases. Automatically, the electrical force, attraction force is a what? Increases. More positive things are where? At a nucleus. Yes, less negative things are available at the outermost orbital. Got it? Or less things are contained in outermost orbital. Yes, and some things are contained in a where more positive things are contained at a nucleus. Got it? Or then automatically what happened? Automatically there is a electrons is always attracted toward the nucleus. And what is ionization energy? We want to remove the electron from outermost orbital. Okay, now there is a more attraction is there. Okay, automatically what happened? There is required more ionization energy to remove that electron. Okay, why? More acception of the nucleus is there. Okay, more acception of nucleus is there. Okay, now in this way, there is a more effective nuclear charge is there on electrons on outermost orbital. We require more number of more amount of ionization energy. More amount of ionization energy is required. I hope you got it. Once again, please note down there is a whatever the relation is there between a charge and as well as the ionization energy. The nuclear charge is directly proportional to nuclear charge is directly proportional to which one? Ionization energy. Okay, clear or not? The charge is increases, nuclear charge is increases, more ionization energy is required. Why? Because the positivity works against the ionization energy. More positivity is increases, more ionization energy is required for us. Yes, next one is atomic size. Atomic size is also main role played in ionization energy. Yes, and it is inversely proportional. It will be there. Yes, atomic energy is inversely proportional to ionization energy. Yeah, it is a simple thing to understand for you. Okay, clear or not? Now there is a when you take atomic size like this, there is very small atomic size it will be there, and one is a container. Yes, big atomic size it will be there like this. Okay, now yes, suppose this is the become the valency of this particular atom or not. This is only become the valency of this atom. This is the become the valency of this atom or not? Yeah, this is the become the valency of this atom. Which one is easy to remove? Which one is easy to remove? Yeah, this is the easy to remove. Okay, clear or not? When we give an energy to this electron, yes, it is easy to remove from it. Okay, clear or not? and when we give the energy to it, it is easy to remove from it. Got it or not? I hope you got it here. Yes, why? Because the size is increases, the nuclear energy on this electron is decreases. Okay, clear or not? The nucleus is not attracted that much in a small size of atom compared with the big size of atom. I hope you got it here. When you take a big size of atom, there is this electron is easily removed from that outermost orbital. Yes, there is a when it is a very small, the atom is a very small. We require a more ionization energy to remove the electron from outermost orbital. The main reason is only the nucleus is a contain a more accepting or a more attraction force on electron when the atom size is small. When the atom size is a big, automatically when the atom size is a big, automatically the electron is what happened? The electron is come out for a small ionization energy only. For a small ionization energy only. Okay, I hope you got it here. Yes, and when the atomic size is increased, suppose you take in a question may ask like that. When you take a groups, in the groups atomic size is increases or not? Yeah, increases it is or not? Lithium to the rubidium and cesium, the atomic size is increases. Which one is required more ionization energy? Lithium is required more ionization energy compared with the cesium or rubidium. Why? Because they contain a 58 atomic number. Yes, and the lithium is a contain only 3. Atomic number is a 3. Got it or not? Yes. I hope you got it here. 3 nothing but there is only 2 orbits. There is a when you take here, yes, a 5th orbit atom. Okay, clear or not? 5th orbit atom. Yes, automatically what happened? 5th orbit atom nothing but yes, 5th orbit when you take it is a 5 orbits are there, which is a contain more size. There is a which are contained in a 5th orbit, it is a contain more size compared with the 2 orbits. When it is a contain 2 orbits, the electron easily contain attraction between the nucleus. Yes, and more attraction contained by the nucleus. But when you check it here, it will be contained somewhat far from it. That much of attraction force is not there. That much of attraction force is not there on this particular. Yes, this is only about our concept of atomic size and there is a nuclear charge. Although students, today's class summary, once check it out. Today we already discussed about the how many types of ionization energies are there and which factors are affecting the ionization energy. As what is the ionization energy? Once again, I am recalled. Once check it. What is ionization energy? Ionization energy is nothing but the amount of energy required to remove the electron from outermost orbital. It is called ionization energy. The amount of energy remove the electron from outermost orbital. It is called what? Ionization energy. The ionization energy is nothing but it makes the ionized. The atom is become ionized. When we provide amount of energy, atom is become ionized. Got it or not? I hope you got it here. Which ion it will form? Cation it is a form. When the more cation nature it will be contained, the cation strength is increases. What happened? The cation strength is increases. What happened? Yeah, when the cation strength is increases, automatically yes, a more positivity is increases and very difficulty to remove the electron from outermost orbital. Yes, when we remove the one electron, that is called the fundamental ionization energy. When we take in the second electron, that is called secondary ionization energy. Yes, and third ionization energy, fourth ionization energy. Which is a more energy is a contain? The fourth one is a contain more ionization energy. Why? Because up to that atom is a become 4 cations. There is a 4 positive ions. It is become as a +4. Yes, it is a very difficulty to remove the electron and by opposing that all protons. Okay, that is why there is a more ionization energy is required. Yeah, the next there is so many factors affecting. Today we already discussed the 2. The thing is a nuclear charge. You know very well what is a nuclear charge. How you will get the nuclear charge? Because of protons. the proton number is increases. Already now only we discussed it. As automatically ionization energy required more. Okay, now yes. Why? Because the protons and electrons are contain one electrostatic attraction force inside the atom. Electrostatic attraction force is there, and because of that, it will be difficulty to remove the electron from the outermost orbital. Got it? And the next, the last next component, atomic size. Atomic size is inversely proportional to ionization energy. Got it or not? Atomic energy, atomic size is inversely proportional to ionization energy. Why? Because inversely proportional. Yeah, because of what? Because of, yes, atomic size is increases. It's not easy to. It is easy to remove the electron from outermost orbital. But when it is a container less size, there is a nucleus effect. It is more on, okay, that a particular electron when it is nearby the nucleus. Suppose it is in a first orbit, very difficult. Helium is required more ionization energy. Okay, compare with the lithium. Okay, now and compare with the lithium, the sodium is easy to remove the electron. Why? Because lithium contain only just 2 orbits. Sodium contain 3 orbits. Yes, somewhat farther from the nucleus. In this way, there is the relations are important. Yes, this is the thing for today. Any doubts, students? Any doubt from any branch? Tomorrow we'll continue the same lesson. And all the students, please write the notes of the lecture 3 also. It's a very important. And whatever atomic size is there, the last class, whatever discussed, it is enough. There is a shielding effect and all the things are given that is not up to level. And it will be contained somewhat more than your knowledge. And just you stop it there only. And tomorrow you complete this ionization energy, and after tomorrow we'll go with the question answers. How to what is the reason for that answers, and we'll go into that particular part. Yes, thank you. Bye, take care.